Let's get right into it. You know how experts, policymakers, and business leaders actually separate hard facts from just, well, guessing? Welcome to this explainer. Today, we're breaking down the precise architecture of how new knowledge is generated and, crucially, validated. If you've ever wanted a complete, detailed explanation of how we move beyond basic intuition to uncover the actual truth, you are absolutely in the right place.
Okay, so think about this fundamental question for a second. Human beings are naturally inquisitive, right? That curiosity is literally the mother of all knowledge. When we hit a wall of the unknown, our gut instinct is to probe and try to figure it out. But here's the thing. Relying on guesswork just doesn't cut it when you're making massive decisions that impact businesses, societies, or scientific advancement. We need a rock-solid, highly reliable mechanism to actually discover the truth.
And to answer that, we're going to take an architect's journey today. Here's our agenda. We'll start with the foundations of scientific research, compare methods versus methodology, explore the types of research approaches, walk through the complete research process, look at the criteria for good research, and wrap up with real-world research challenges. All right, Section 1, Foundations of Scientific Research. We've got to start at the bedrock to make sure we're all on the exact same page about what genuine academic pursuit actually looks like.
So the biggest takeaway here is that research isn't just, doing a quick internet search or skimming a library book. As experts like Clifford Woody define it, it's a highly structured voyage from the known to the unknown. It's a systematic method. You're enunciating the problem, formulating a hypothesis, collecting data, analyzing facts, and reaching conclusions. It's an active, deliberate pursuit of truth meant to make an original contribution to our existing stock of knowledge.
Moving on to Section 2, Methods versus Methodology. Now, this is a distinction that trips up a ton of students and professionals alike, so let's clear it up. Think of it like an architect designing a skyscraper. Research methods, those are your hammers, your nails, your measuring tapes. They are the actual techniques and instruments used to do the physical work, like running a survey or conducting a lab experiment. But the methodology, that's the master blueprint. It's the science and logic explaining exactly why those specific tools are being used in the first place. Methodology demands that you don't just know the techniques, but you fundamentally understand the underlying logic. You have to be able to justify why you're using one specific test over another, so that anyone else can independently evaluate your results. Make sense? Let's hit Section 3, Types of Research Approaches. Just like buildings are designed differently based on what they're used for, investigations need different frameworks depending on the exact problem you're trying to solve. This taxonomy is incredibly useful because it shows us exactly which tool to grab from the toolbox. For instance, if a government just wants to report on the current shopping habits of its citizens, they'd use descriptive research. But if they want to critically evaluate why an economic policy failed, they'd pivot to analytical research. Then you have applied research, which is all about fixing immediate, pressing societal or business problems, versus fundamental research, which is formulating theory just for the sake of gathering knowledge. We also look at quantitative research, which expresses phenomena in rigid, measurable numbers, versus qualitative research, which dives deep into subjective behavior and underlying human motives. And finally, conceptual research helps philosophers develop or reinterpret abstract ideas, while empirical research relies entirely on hard, concrete, data-based experience. Picking the right combination here is the whole secret to good methodology. Okay, Section 4, the complete research process. We have our blueprint, we know our materials, so now it's time to actually construct the study, step by step. What's really fascinating about the complete research process is how it maps the lifespan of a project not as a straight line, but as a continuous loop. While we number these stages to keep things organized, in practice they overlap constantly. Like, you might be collecting data and realize you need to tweak your hypothesis. It's totally dynamic. But for clarity's sake, let's break this sequence down into two main phases, design and execution. Steps 1 through 5 are our design phase. Step 1, formulate your research problem, zeroing in on exactly what you want to solve and clearing up any ambiguity. Step 2 is an extensive literature survey, basically checking academic journals so you don't waste time reinventing the wheel. Step 3 is developing your working hypotheses, which are those tentative assumptions that guide your logic. Next up, Step 4, you prepare the research design to figure out how you'll get maximum evidence with minimum effort and spending. And Step 5 is determining the sample design. Since you can't exactly survey everyone on Earth, you pick a representative subset. That might be random sampling, stratified sampling by demographic, or deliberately handpicking specific experts. Then we shift into pure execution for the final 6 steps. Step 6, actually collect the data.
Get out there and observe or interview. Step 7, officially execute the project. Step 8, analyze that massive pile of raw data, categorizing and tabulating it into manageable statistics. Then, Step 9 is hypothesis testing. This is where you run rigorous statistical tests, like chi-square or t-tests, to mathematically prove if your results are scientifically significant or if they were just a fluke. Step 10 is generalizations and interpretation, where you actually build general theories based on what held up. And, finally, Step 11, prepare the report. Because if you don't write it down clearly, how is the rest of the world supposed to benefit from all your hard work?
That brings us to Section 5, criteria for good research. We've built the study, but how do we know it won't just completely collapse under scrutiny? Well, if we're going to base major government policies or corporate business moves on research, it absolutely has to pass these 4 critical tests. 1, it must be systematic, meaning it strictly follows those specified steps without relying on random guessing. 2, it has to be logical, heavily guided by the rules of induction and deduction. 3, it must be empirical, based on concrete real-world data that provides external validity. And 4, this is a massive one, it must be replicable. Literally anyone else following your exact methodology should end up at the exact same destination. That replicability is the very cornerstone of scientific trust.
Finally, Section 6, real-world research challenges. Because as we all know, theoretical perfection usually crashes hard into real-world limitations. To put this into perspective, our source looks at empirical researchers in India to show us exactly what happens when the ecosystem isn't fully supported. You see a real lack of scientific training in methodology, which turns rigorous science into a messy guessing game. There's often insufficient interaction between university academics and actual industry pros, leaving huge gaps in the data. Throw in corporate secrecy, where businesses hide data due to strict corporate cultures, plus duplicated studies that just waste resources, no unified code of conduct, and inadequate computational assistance. Well, you get the picture. It shows us exactly why a robust methodology is an absolute necessity, not just some academic luxury. I want to leave you with this incredible quote from Hudson Maxim. All progress is born of inquiry. Doubt is often better than overconfidence, for it leads to inquiry, and inquiry leads to invention. Mastering this stuff isn't just about passing a class or writing a report. It's the literal blueprint for how we invent a better future. It requires us to ditch the overconfidence and systematically seek out the truth. So, are you ready to question your own overconfidence and start building a better truth? Thanks for tuning into this explainer, and keep questioning the unknown.